Alrighty guys, let's take a look at example number 2. So this one's going to be a little more complicated because the denominators are no longer monomials. So we're going to need everything in a factored form to start off. So take a minute, copy the problem down. And then when you're ready, you want to go through and you want to factor your trinomials so that you can try to figure out what's going to happen as far as your least common denominator. Okay? So I'm going to start working on factoring those trinomials. The good news is the trinomial in the second term and the third term are the same, so we don't have as much factoring to do as we normally would. All right, so I'm looking for factors of negative 15 that add up to 2. So that's going to be x plus 5 and x minus 3. And this is also x plus 5 and x minus 3. Okay? And then if I compare that with the original denominator here, this just needs a slight modification to it to match the others, okay? So if I take this one and multiply it by x minus 3, all three denominators would have the same two binomials involved, all right? So I'm going to write off to the side over here that our least common denominator is equal to x plus 5 times x minus 3. Let's go ahead and make our domain restrictions right there, so that we know what numbers we cannot have for final answers. So from here, we know that x is not allowed to equal negative 5 from the first factor equal to 0, and positive 3 from the second factor equal to 0. So if we get x equals negative 5, or if we get x equals 3, that's going to end up being extraneous solutions. Those are numbers that we can't plug into the original equation because it'll make one or more of the fractions undefined. Okay. So now we want to go through and make everything have that common denominator so that we can go through and solve this equation. So if we think about making them all have a common denominator here, this one I just need to multiply by x minus 3. So I'm going to take the numerator, x plus 8, and multiply it by x minus 3, like that. Okay? So that's going to replace this fraction. I have to subtract. This already has the LCD, so I just have to subtract this whole thing. The important thing, though, is that you realize you have to subtract the entire expression. The one biggest mistake I see with solving rational equations is forgetting to distribute the subtraction sign. So make sure you're watching out for that, because that pops up pretty often. Okay? And then over here, I already have the common denominator, so the numerator does not need to be modified. Okay? So now, technically, I could write that this is over the LCD, this is over the LCD, and this is over the LCD. But because all those common denominators would be common, it's not really necessary to write it. We can just write all the numerators down. And that's exactly what would have happened if I took this fraction, multiplied it by this, the x plus 5s would have gone away, and I would have had x plus 8 times x minus 3. All right? So you don't even necessarily have to write your common denominator under every single piece. All right. So now I'm going to need to FOIL here, distribute the subtraction sign, and try to solve this equation. So now I'm going to have x squared minus 3x plus 8x minus 24. Distribute that subtraction sign like so. I'm going to get minus x minus 7 is equal to 1. If I look at this now, I have a quadratic equation because my highest degree is x squared. So I'm going to go through and try to solve this by factoring. So I want it to say equals 0. All right, so combine your like terms. That'll be plus 5x. So here's plus 5x minus one more x is going to be plus 4x. Negative 24 minus 7 is negative 31. Take away one more, and you're going to get negative 32. And this is now something that we can solve by factoring. Keep in mind, it doesn't have to solve by factoring. We could always use the quadratic formula instead. So whichever method is faster for you, that's what I want you to use. But this factors pretty easily. We want factors of negative 32 that add up to 4. So there's going to be an 8 and a 4, because 8 times 4 is 32. I want a positive 4, so we need a plus 8 minus 4. This is equal to 0. So we get x is equal to negative 8 and positive 4. Now that we have those answers, we go back and we compare to our domain restrictions up here. And neither of our answers were negative 5 or 3, so that means both of our answers will work. So we get x equals negative 8 and x equals 4 for the final answer to this problem. Okay? So there's example number 2.